the lab today was the first time we saw recursion as it relates to binary trees. And we'll see it with binary search trees as well. And we talked before when we talked about recursion that it's not the most efficient. It uses memory a lot. But we talk about it, and it's a thing because there are times when it's the only way you can get done what you want to get done in any kind of reasonable version. And that's the case with trees. So when we have a binary tree, we know where the root's at, but everything else we got to get to. Okay, so by making recursive calls, we can, in just a few lines of code, go through the entire tree and print it out or do whatever we need to do. So that can be a little confusing. So I thought we could, in this video, we'll take a little time to try to figure this out. So here we have a basic tree. It's a binary tree. Okay. Um, this one ends up being a binary search tree, but it doesn't have to be. Any tree should work. And again, if you didn't see the announcement, if you were in the first section today, I'd mistakenly I'd misremembered and forgotten that we weren't dealing with a binary search tree. So the original assignment for the lab had said that you've got it right when it prints out an order. The tree itself wasn't in order, so it was never going to print out in order. So this is what your code should have looked like. I mean, it's a little bit different. I don't have the constructor here, but basically in our in-order traversal function, it's going to take the tree node root, okay, a pointer to a tree node called root. Again, this is not the root of the tree, so this does not always equal 4, okay? We're going to use this to recursively call it on all the different nodes. So if I call this on node 3, then root data is 3, okay? But when we start, we'll start at the top because that's the only place we know. Okay. And again, this is our base case here. If the root is equal to the null pointer or it's empty, then we know we're done. Okay. So we return. We do nothing else. But if not, remember for the in-order traversal, we start by traversing the left subtree and then visit the node and then the right subtree. Okay. So to traverse the left subtree, we're going to recursively call the in-order function again. Okay. So remember what happens with recursion. So when we first call this, 4 will be root. We get to here, it will say, because that's not null, it'll say go ahead and call the function again on the left child. Okay. So we were at 4. Now that's on pause. I mean, that's still out there in the system, but it's on pause while we go to the 2. Okay. The 2 starts back up at the beginning and checks to see, nope, it's not null. So now it gets to this one and it says, okay, need to go left again. So it starts a third version. So at this point in the code, the function, there are 3 copies of itself. There's the function where 4 is the root, there's the function where 2 is the root, and there's the function where 1 is the root. Okay? So we're going to come back around one more time. Okay? Is root equal to null? No, it's not. We're going to try root left one more time. That one more time that we try it will be on null. So then that will collapse down. We'll get back to 1. Okay? So for the version of the function that the root is 1, we've already done that. Now we're back. So now we're going to print out. Root data is 1. Print out the 1. Okay? Our next job is to call the right tree. Okay? Well, we're going to call the right tree. The right child is a null. So the next time the loop comes around, that'll be done. Okay? And we're back to the 2. Okay? When we left the 2, so we had done this, right? We've done the left. Now we're going to print out the value. We print out the 2. Now we're going to follow the right path down to here. Note that the 2 is still open and the 4 is still open. 3 is going to try to go left. It can't. Comes back. It's going to print out the 3, try to go right. It can't. Goes back to 2. Okay? So the 2 has now gone to 1, printed itself out, and gone to 3. It's done. It goes back to the 4. 4 has tried the first one. It's gone left. Now it's back. So now it's going to print out 4. That's the root data. Now it's going to go to here. Okay. When we're at 6, 6 is going to try to go left. It can't. It'll print itself out. So 6 gets printed next. Okay. Goes to the right. It goes to 7. 7 tries to go left. It can't. Prints itself out. tries to go right. It can't. Now this closes, that closes, that closes, and we're done. So this code will take us through 1, 2, 3, 4, 6, 7. Okay. So this is another way to look at this. Okay. We start with the in order on 4, which calls the 2, which calls the 1, which then goes to the null pointer, which hits return. It prints the 1. It calls the null pointer again. Now it prints the 2. It's back on this 2 level. Okay. And then after it does that, it goes to 3. The 3 can't go left, prints 3, tries to go right, can't. It comes back to here. It finally prints the 4, and then it goes down the other side. Okay. And the maximum number of indentations here, the maximum number of functions working at the same time are going to be 3. And we can see that because we have 3 layers of the tree. Okay. If there are more, there'd be more of those packed in there. Okay. And then we can also look a bit at the call stack visualization on this. So again, when we start, we have the in order 4, and that's our stack, okay, from top to bottom, okay? Remember the stack, things get pushed on to the stack, and they get pulled from the top. They get pushed to the foot, they get added to the top, and they get removed from the top, okay? So it's the first in, last out, okay? Or last in, first out, if you prefer. So this is the original call. It's going to go left, which calls 2 in order 2. So now it's on top. Go left again, calls in order 1, goes to here. We now have 1, 2, and 4 all in memory. Okay. 4 is waiting on 2, 2 is waiting on 1. The left of 1 is null, so we return. Now we get back to the 1, or the 2, and the 4 are there. Okay. Then we print the 1, okay, and keep going down, and that's going to be the output of that. Okay. So again, if you have a binary search tree, the in order traversal will always print out in order. Okay. So hopefully this makes some more sense. We're going to be seeing this a lot with our data structures. I mean, the delete worked the same way, very similar. Okay. If we want to look at the delete tree, also a void function from the lab, it also took a tree node star root. Okay. This has the same base case. Get my font correct here. This has the same case, base case. So if root is equal to null pointer, then we know we're done. And we can just do a return. Okay. If not, we're still going to do, we're going to have to follow the left tree, just like before. So we have the delete tree at root left. Okay. But this time, before we can delete root, we have to do the delete tree of the root right. And we'll talk about this visually here in a minute, what's happening. Okay. So we've made sure, again, we can only delete leaf nodes. So we're checking, are there any left children? We're going to recursively check until we have no more left children. Then we're going to check the right children. When we're done checking left and right, when the control returns back to here, after doing the left and doing the right, then we know that we have a leaf node and we can go ahead and delete the root. Okay. Again, the root is the local root, not the root for the whole tree. Okay. So let's look how this would work. We start with calling the delete tree on 4, and it says go left. So it goes left. Call it on 2. We now have 2 versions running. It's going to go left to 1. Okay. 1 is going to check left and right. They're both empty. So now it's going to delete. Okay. It then goes back up to the 2. With 2, we've checked left, but we didn't check right. We check right. We go to here. We check left. We check right. We delete. So now we're back to here. We're still here. We have done the left and the right now, so we can delete this one. Okay. That gets us back to here. So we started from here. We went left. Now we're going right, which gets us to here. Okay. From here, we try to go left. We can't. We go right. Okay. We get here. Left and right both null. That's gone. We're back to here. Left and right are null. That's gone. We're back to here. Left and right are null. And we're done. Okay. So that's going to take care of the tree. Okay. And it will be empty. Okay. So hopefully this clears up some confusion on that. If not, it's worth getting some pencil and paper and go through an example yourself to make sure you really understand what's going on here. And of course, if you have any questions, then definitely either text me or ask me in class tomorrow.